Okay, thank you. Assalamu alaikum. Hello, everyone. We are Group 7. Our project name is Digital Twin Framework for Transportation Management, and it's a big honor to present it here today. Our team combines diverse expertise in different fields. Together, we aim to show how digital twins can transform transportation systems into smarter and sustainable networks.
That's Aista.
Our story says we are living at an extraordinary time in a human history. Riyadh is experiencing a defining moment, a city at the crossroads of innovation and transformation. This video captures our daily reality. Imagine waking up early every day, knowing you will spend almost 90 hours this year, essentially 4 full days, and sitting motionless in traffic. 90% traffic density, thousands of vehicles gridlocked. But what if we could change this story? What if technology could predict, prevent, and transform this chaos into coordinated flow? And that's our mission today. Riyadh has become a leading technology hub, hosting major events all year. The demand on the city's infrastructure will rise even more with upcoming Expo and the World Cup. In the meanwhile, Riyadh's historical trends analysis, as we see exponential growth in both population and vehicle numbers. Our crisis findings through data-driven evidence as follow. Economic burden, population pressure, increase in accident rate, navigate impacts on public safety, regional leadership's position, unsustainable growth patterns, and fragmented transport modes, each demanding integrated digital solutions. Through the alignment of strategic goals, which include sustainable transport, climate action, smart city innovation, and a higher quality of life, Riyadh is transforming into a truly green and smart global city. Our commitment as a smart city managers is to find solutions that are inclusive, ensuring that no one is left behind, and to work towards making every journey in Riyadh smoother, safer, and more connected.
Thank you, Eman. This is me, Noor. I will walk you through the benchmarking phase of our project, where we studied how three regional cities, Doha, Dubai, and Cairo, addressed their transportation challenges and what lessons we could bring to a Riyadh digital twin framework. Each city at a different stage of smart transformation, yet all share the same goal, making mobility smarter, safer, and more sustainable. Our aim wasn't just to compare them, but to extract what truly works and apply those proven practices to a real transportation ecosystem. Let's start with our first case, at Doha. The city challenge was keeping people and traffic moving smoothly during times of high demand. Through TASMO Smart Qatar program, Doha built a national digital twin platform that connected ministries and transport operators, allowing real-time coordination and predictive management. For Riyadh, we adopted the same approach by designing a digital twin that predicts mobility patterns and support proactive planning, and keep the city agile and connected. Second is Dubai. The main challenge was data fragmentation. Too many systems working in silos and not enough skilled team to connect them. Through Digital Dubai initiative, the city introduced a unified data governance and built human capacity through AI and data training. For Riyadh, we applied these lessons by building a unified data environment and a capacity building pillar to ensure digital twin evolves sustainably over time. For our latest reference is Cairo. In Cairo, the main challenge was fragmentation of many informal transport routes and little visibility into how people actually moved across the city. Projects like Transport for Cairo, mapping these networks, showing the true smart transformation start with understanding people, not just technology. That's why Our digital twin framework for Riyadh was built around human experience, integrating citizen feedback and focus on lead pain points like congestion and safety. Together, these shaped a human-centered framework. And here, this is how we moved from benchmarking to a building phase. Thank you, everyone.
Thank you, Noor. Our project adopted an agile methodology to ensure flexibility, continuous improvement, and effective team collaboration. Our final master's project worked in a way that simulated a geographically separated team of experts planning and designing a digital twin. We utilize online tools such as WhatsApp for instant messaging and idea generation, Zoom for online meetings and screen sharing, and Google Drive for shared document management, collaborative editing, and centralized file storage. This integrated approach enabled efficient communication, transparent task allocation, and timely feedback, ultimately enhancing the quality and productivity of our project work. The digital twin framework is conceptually structured to ingest, process, and unify data from two primary data categories. Static foundational data provides the immutable geographic and structural context. This includes roads, administrative boundaries, and points of interest. Dynamic operational data provides the real-time or near real-time state of the transportation system. The framework is designed to interface with real-time feeds such as vehicle GPS, sensors, CCTV cameras, and geocoded records of traffic accidents. Geographic information systems are the data integration and spatial visualization backbone of the digital twin framework. GIS has the ability to hold a vast amount of data that can be easily stored, shared, analyzed, and managed. It provides a platform for spatial data analyses and visualization to explore relationships between spatial and non-spatial data. While the primary focus of our report was a digital twin framework, we also considered how other approaches, such as policy options, could address urban transportation challenges. In general, sustainable transport policies encourage the use of public transport, bicycles, and walking, and discourage the use of individual motorized modes of transport, such as cars and motorcycles. The easy conceptual framework can be used to illustrate strategies to enable, avoid, shift, and improve opportunities and challenges related to urban transportation. Strategies include adopting cleaner vehicle technologies, implementing fuel and road pricing policies, promoting public transport and non-motorized travel, land use and transport planning, and using smart technologies to optimize traffic flow and resource use. Sustainable urban transportation supports economic development while minimizing negative environmental and social impacts, ensuring that urban mobility meets present needs without compromising the ability of future generations to move safely and efficiently.
Thanks, Duncan. Hello, everyone. This is Hesham. To build a trusted and scalable solution, our work is grounded in international standards and proven frameworks. We began with the official ISO definition of digital twin, a virtual representation synchronized with physical entity through live data connections. To realize this in a structured way, we use the Digital Twin Consortium's capabilities periodic table as our guiding blueprint. It's important to note that this is not a rigid checklist, but a customizable framework. It allows us to select and prioritize the capabilities that deliver the most value for urban transportation. By applying this tailored approach, we create a unified city-agnostic platform. It integrates all critical elements from roads and buildings to live vehicles, enabling the powerful simulations and real-time operational control that you will see in the following demo. This foundational strategy ensures our digital twin is a practical, standards-based decision-making tool adaptable to the unique needs of any city. This demo shows a proof of concept for a digital twin used in transportation management. It brings together data from Esri 3D base maps, OpenStreetMap layers, BIM models, and a live tracking web service. Clicking any transportation facility shows a pop-up with its details, for example, whether it's a metro station or a bus station and its name. There are three main layers: transportation facilities, roads, buildings. Every element in the model is linked to a database record. Selecting an item in the model highlights it in the database and the other way around. We move from simple 3D masses to full BIM models with floor awareness. This supports indoor and outdoor movement in one view. This has clear use cases in Riyadh, like guiding someone from the airport to their exact seat in a stadium during the upcoming Asian Cup, World Cup, or Expo. It's not only visuals. You can access information for different BIM elements as it is in its BIM authoring tools. The digital twin supports simulations. Daylight simulation can show shadow coverage to plan waiting areas with longer shade. Also, weather simulation can help manage transport in heavy rain or fog. The solution also connects in real time with vehicles. Here we show buses for monitoring. Red areas reflect construction zones across Riyadh or places with incidents or high crowding. This helps plan bus routes more effectively.
Thank you, Hesham. This education and capacity building chart, as you can see, aligns closely with the digital twin framework project by outlining the human and institutional development needed to support data-driven urban innovation. It connects awareness, skills, and collaboration to the practical application of digital twin technologies in planning, monitoring, and decision-making. Through training, workshops, and mentorship, it prepares stakeholders to manage digital systems effectively, fostering inclusive, sustainable capacity. As you can see, people, data, technology, and process are interconnected with each other. Moving on to the citizens' engagement survey, as you can see, this survey explores public perceptions of urban mobility in Riyadh, focusing on the potential of digital twin technologies for sustainable transportation. Participation is voluntary, anonymous, and strictly academic. The survey is designed with structured sections, including demographic data, mobility behaviors, and awareness of smart technologies. It uses multiple choice and Likert scales questions to collect both quantitative and qualitative insights. It is translated to Arabic as well for more inclusive. The data was cleaned and analyzed using Excel and Power BI dashboard to come up with the conclusions and recommendations. Though the sample was small due to certain limitations, it was sufficient to provide preliminary insights and identify key trends relevant to the development of Riyadh Digital Twin Framework. As you can see, several themes have arisen in this dashboard. If you click on the acceptance and digital twin concerns, you are going to find that 40% of them goes to data privacy as a concern. Digital twin awareness, you are going to see that 60% are not familiar with digital twin. Regarding the challenges and satisfaction, transport challenges, 53 goes to traffic congestion as the main traffic challenge. Once click on current travel pattern, transport modes, you will see that 72% of Riyadh citizens are using their private cars. Public perceptions points to a clear opportunity that Riyadh citizens want solutions to congestion, faster emergency responses, and more efficient mobility. They trust government agencies to deliver, but expect robust data privacy protection. Awareness campaigns should emphasize tangible benefits, ensuring the digital twin serves not only as a planning tool, but also as a citizen-focused service. Regarding the recommendations, there is a need to launch a public education campaign highlighting tangible benefits, and to begin with modules addressing real-time traffic and emergency responses. And last, to establish a transparent public data governance policy. Thank you all for your attention. I look forward to continuing this journey of research and innovation, and we hope all it will serve as a valuable foundation for future studies in the field. Thank you, ZIGURAT. Thank you, Mr. Kress. Thank you, Mr. Khalid. And at the end, thank you all team members.